Welcome to Tech with Kaushik. This is part 12 of our complete practice question series for the AZ-400 Microsoft Certified DevOps Engineer Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 12. Question number 494. Scenario. An Azure Container Registry contains a repository named Payment API. A deployment system exposes an HTTPS endpoint that must receive a notification whenever a new image version is pushed to that repository. What should you configure? The available options are as follows. Option A. An Azure Container Registry webhook for push events scoped to the Payment API repository. Option B. An Azure DevOps scheduled pipeline with no registry trigger. Option C. An Azure Board Service hook for work item updates. Option D. A registry retention policy for untagged manifests. The correct answer is option A. An Azure Container Registry webhook for push events scoped to the Payment API repository. Here's why. An ACR webhook can send an HTTP post notification when an image is pushed and can be scoped to the required repository or tag pattern. Why are the other options not correct? B. A schedule does not react immediately to registry push events. C. Azure Board Service hooks monitor work tracking events. D. Retention policies delete eligible manifests and do not notify deployment systems of new images. Exam tip. Use ACR webhooks when an external endpoint must react directly to image push or delete events. Question number 495. Scenario. A DevOps team uses a bicep template to provision Azure infrastructure. Before the release pipeline executes the final deployment, the pipeline must generate a preview of the specific resources that will be created, modified, or deleted without applying any changes to the target Azure resource group. Which capability should the pipeline invoke? The available options are as follows. Option A. A bicep what-if operation. Option B. An Azure Policy Compliance Scan. Option C. The Azure Resource Manager Template Validation API. Option D. A bicep linter task. The correct answer is option A. A bicep what-if operation. Here's why. The what-if operation, or ARM template what-if, predicts how resources will change if the template is deployed. It outputs a clear list of creations, modifications, and deletions without making any actual changes to the Azure environment. Why are the other options not correct? B. Azure Policy evaluates resource configurations against compliance rules, but it does not generate a diff of state changes. C. Template validation checks syntax and structural validity, but does not query the current Azure environment to produce a state change preview. D. A linter checks code quality and formatting before compilation, but it cannot predict environmental changes. Exam tip. Use validation for syntax checking, what-if for state change previews, and Azure Policy for compliance enforcement. Question number 496. Scenario. An e-commerce platform is composed of several microservices deployed to Azure Kubernetes Service, AKS. The operations team must visualize the end-to-end path of individual user requests as they travel across the different microservices to identify latency bottlenecks. Which Azure Monitor capability should the team use? The available options are as follows. Option A. Application Insights Distributed Tracing and Application Map. Option B. Azure Monitor Agent, AMA, syslog collection. Option C. Azure Kubernetes Service, AKS, Container Insights Node Metrics. Option D. Network Watcher Connection Troubleshoot. The correct answer is option A. Application Insights Distributed Tracing and Application Map. Here's why. Application Insights Distributed Tracing tracks requests across multiple services and components. Application Map visualizes this topology, allowing engineers to see the end-to-end transaction flow and identify bottlenecks between microservices. Why are the other options not correct? B. AMA syslog collection gathers infrastructure OS level logs, which cannot track application request flows. C. Node metrics monitor AKS infrastructure performance, CPU/memory, but do not trace application-level transaction paths. D. Network Watcher Connection troubleshoot diagnoses network-level connectivity issues, not application request tracing. Exam tip. When you need to visualize cross-component requests in a microservice architecture, rely on distributed tracing and application map. Question number 497. Scenario. An Azure pipeline deploys a web application to Azure App Service. The application must receive an environment variable named page_limit with the value 75. What should the deployment configure? The available options are as follows. Option A. An app service application setting named page_limit with a value of 75. Option B. An Azure DevOps agent capability named page_limit. Option C. An Azure Boards field named page_limit. Option D. A deployment slot traffic percentage of 75. The correct answer is option A. An app service application setting named page_limit with a value of 75. Here's why. App service exposes application settings to the application as environment variables at runtime. Why are the other options not correct? B. Agent capabilities affect pipeline job demand matching. C. Azure Boards fields store work item data. D. Traffic routing controls the percentage of requests sent to a deployment slot. Exam tip. Use app service application settings for runtime environment variables and mark slot-specific values as deployment slot settings when required. Question number 498. Scenario. A team deploys an Azure App Service application through a CI/CD pipeline. New releases must be validated in an isolated app service environment before production traffic is switched to them. What should the team create? The available options are as follows. Option A. A staging deployment slot. Option B. An additional Azure DevOps organization. Option C. A log analytics table. Option D. A second source control branch with no deployment target. The correct answer is option A. A staging deployment slot. Here's why. A deployment slot provides an isolated app service endpoint where a release can be deployed, warmed, tested, and later swapped or assigned production traffic. Why are the other options not correct? B. Another Azure DevOps organization does not create an application environment. C. Log Analytics stores telemetry rather than hosting a staged release. D. A branch alone does not provide an isolated deployment endpoint. Exam tip. Deployment slots separate deployment and validation from the final production traffic switch. Question number 499. Scenario. A new application version must initially receive only 10% of production traffic. The remaining users must continue to use the existing version, and the solution should use native Azure App Service functionality. Arrange the required actions in the correct order. The available items are as follows. Item 1. Configure production traffic routing so that 10% is sent to the non-production slot. Item 2. Deploy the new application version to the non-production slot. Item 3. Create a deployment slot for the new version. The correct sequence is as follows. First, create a deployment slot for the new version. Second, deploy the new application version to the non-production slot. Third, configure production traffic routing so that 10% is sent to the non-production slot. Here's why. The slot must exist before it can receive the release. After deployment, app service traffic routing can expose the new version to the required minority of users. Exam tip. Use slot traffic routing for percentage-based progressive exposure and a slot swap for complete cutover. Question number 500. Scenario. Multiple Azure Boards teams deliver related features across several projects. Program managers must view the teams on a shared timeline and identify predecessor and successor relationships between their work items. Which solution should they implement? The available options are as follows. Option A. Create an Azure Boards delivery plan that includes the teams and use predecessor and successor links for dependencies. Option B. Use parent and child links to represent every cross-project dependency. Option C. Add a dashboard query that contains no dependency relationships. Option D. Create separate Kanban boards that cannot display work from other projects. The correct answer is option A. Create an Azure Boards delivery plan that includes the teams and use predecessor and successor links for dependencies. Here's why. Delivery plans provide a cross-team, cross-project timeline, while predecessor and successor links identify producer-consumer dependencies between work items. Why are the other options not correct? B. Parent and child links represent hierarchy rather than delivery dependency. C. A query alone does not provide the required timeline and dependency visualization. D. Separate boards do not provide an overview across projects. Exam tip. Use parent and child for hierarchy and predecessor and successor for delivery dependencies. Question number 501. Scenario. A cloud architect is designing an instrumentation strategy for a distributed application using Azure Monitor Application Insights and OpenTelemetry. Evaluate each statement. Select yes if the statement is true. Otherwise, select no. Statement 1. Application Insights telemetry data can be queried using Kusto Query Language, KQL. Statement 2. OpenTelemetry metrics and distributed traces can be natively ingested into Application Insights. Statement 3. Application Insights auto-instrumentation requires modifying the application source code for all supported frameworks. Statement 1. Application Insights telemetry data can be queried using Kusto Query Language, KQL. The answer is yes. The underlying data store is a log analytics workspace queried via KQL. Statement 2. OpenTelemetry metrics and distributed traces can be natively ingested into Application Insights. The answer is yes. Azure Monitor provides full support for OpenTelemetry SDKs and exporters. Statement 3. Application Insights auto-instrumentation requires modifying the application source code for all supported frameworks. The answer is no. Auto-instrumentation allows telemetry collection without code changes for supported services like Azure App Service. Exam tip. Prefer OpenTelemetry for vendor-neutral instrumentation and auto-instrumentation to minimize code changes when onboarding legacy apps to Azure Monitor. Question number 502. Scenario. A .NET web application sends telemetry to Application Insights. After one application deployment, administrators must be able to change the percentage of telemetry retained by Application Insights without redeploying the application again. Complete the sampling design. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. In the application configuration, the blank. The choices for Statement 1 are disable SDK-based adaptive sampling, enable fixed-rate SDK sampling, or enable duplicate telemetry processors. Statement 2. In the Application Insights resource, the blank. The choices for Statement 2 are modify ingestion sampling under usage and estimated costs, configure smart detection, or enable continuous export. For Statement 1, the correct selection is disable SDK-based adaptive sampling. This prevents the SDK from applying an independent sampling decision before transmission. For Statement 2, the correct selection is modify ingestion sampling under usage and estimated costs. Ingestion sampling is controlled by the Application Insights service and can be changed without redeploying the application. Exam tip. SDK sampling reduces transmitted telemetry. Ingestion sampling discards telemetry after it reaches the Application Insights endpoint. Question number 503. Scenario. Several microservices emit distributed traces through different vendor-neutral telemetry libraries. The traces must be exported to Azure Monitor Application Insights by using libraries with Azure Monitor exporters or supported migration integrations. Which two telemetry libraries satisfy the requirement? Select 2. The available options are as follows. Option A, Honeycomb. Option B, OpenTracing. Option C, Jaeger. Option D, OpenTelemetry. Option E, OpenCensus. The correct answers are Option D, OpenTelemetry, and Option E, OpenCensus. Here's why. OpenTelemetry has the current Azure Monitor exporter and distribution. OpenCensus historically provided Azure Monitor exporters and represents the legacy integration path from which applications should migrate. Why are the other options not correct? A. Honeycomb is an observability backend rather than the Azure Monitor exporter standard. B. Open Tracing defines tracing APIs but does not provide the direct Azure Monitor exporter identified here. C. Jaeger is a tracing implementation and backend, not the selected direct application insights exporter path. Exam tip. Prefer OpenTelemetry for new Azure Monitor instrumentation. Treat OpenCensus as a legacy migration technology. Question number 504. Scenario. An ASP.NET Core application uses the Application Insights SDK. The application must sample telemetry at a fixed percentage before the telemetry leaves the process. Where should the sampling processor be configured? The available options are as follows. Option A. In the application startup or service registration code. Option B. In the Application Insights continuous export settings. Option C. In an XML application insights.config file used only by classic ASP.NET. Option D. In the Azure DevOps project level retention policy. The correct answer is option A. In the application startup or service registration code. Here's why. ASP.NET Core configures application insight services and telemetry processors through dependency injection in startup or application builder code. Why are the other options not correct? B. Continuous export does not control client-side sampling. C. Application Insights.config is associated with classic ASP.NET SDK configuration rather than the normal ASP.NET Core service registration pattern. D. Pipeline retention does not affect application telemetry sampling. Exam tip. Configure SDK sampling in application instrumentation code. Configure ingestion sampling in the Application Insights resource. Question number 505. Scenario. An Azure DevOps YAML pipeline must deploy an Azure Resource Manager template to an Azure subscription. Organizational security policy strictly prohibits the use of stored client secrets, certificates, or personal access tokens for authenticating pipelines to Azure. Which authentication method should the team configure for the pipeline service connection? The available options are as follows. Option A. Workload Identity Federation, OpenID Connect. Option B. A service principal with a client secret stored in Azure Key Vault. Option C. A managed identity assigned to the Azure DevOps organization. Option D. An Azure Resource Manager service connection using Publish Profile. The correct answer is option A, Workload Identity Federation, OpenID Connect. Here's why. Workload Identity Federation uses OpenID Connect, OIDC, to establish a trust relationship between Azure DevOps and Microsoft Entra ID. It issues short-lived tokens automatically, entirely eliminating the need to generate, store, or rotate client secrets or PATs. Why are the other options not correct? B. Using a service principal with a client secret violates the policy prohibiting stored secrets. C. Azure DevOps organizations do not use managed identities to authenticate pipeline deployments to Azure subscriptions. D. Publish profile authentication relies on a downloaded credentials file, secrets, which violates the security policy. Exam tip. Always prefer Workload Identity Federation, OIDC, over service principal secrets when configuring Azure Resource Manager service connections. Question number 506. Scenario. A GitHub enterprise organization contains private repositories. The security team must enable push protection to block developers from accidentally committing supported credentials into these repositories. What licensing prerequisite must the organization satisfy to use this feature on private repositories? The available options are as follows. Option A. Assign GitHub Advanced Security, GHAS, licenses to the active committers. Option B. Purchase GitHub Copilot for Business. Option C. Upgrade the organization to a GitHub Enterprise Support Plan. Option D. Assign Microsoft Defender for Cloud DevOps Security licenses to the repositories. The correct answer is option A. Assign GitHub Advanced Security, GHAS, licenses to the active committers. Here's why. While secret scanning is free for public repositories, enabling secret scanning and push protection on private or internal repositories requires a GitHub Advanced Security, GHAS, license for active committers. Why are the other options not correct? B. GitHub Copilot is an AI developer tool and does not provide repository secret scanning features. C. Enterprise support plans provide technical assistance, but do not include GHAS security features. D. Microsoft Defender for Cloud DevOps Security integrates security findings, but does not replace the fundamental GHAS license required natively in GitHub for push protection. Exam tip. Secret scanning is free for public repositories, but GitHub Advanced Security, GHAS, licensing is strictly required to enable it on private repositories. Question number 507. Scenario. Developers use Windows workstations and Azure repos Git. Large binary assets must be stored outside normal Git object storage, while pointer files remain versioned in the repository. Arrange the workstation configuration actions in the correct order. 2 items will not be used. The available items are as follows. Item 1. Configure the required file patterns by running git lfs track. Item 2. Install Git for Windows with Git large file storage. Item 3. Install Scalar instead of Git LFS. Item 4. Authenticate to Azure repos by using the approved Git credential mechanism. Item 5. Configure an unrelated deployment group agent. The correct sequence is as follows. First, install Git for Windows with Git large file storage. Second, authenticate to Azure repos by using the approved Git credential mechanism. Third, configure the required file patterns by running Git LFS track. Here's why. The Git LFS client must be available before LFS commands can be used. After repository access is configured, Git LFS track creates pointer file rules that are committed through the normal Git workflow. Exam tip. Git LFS stores pointer files in Git, while large binary content is maintained in separate LFS object storage. Question number 508. Scenario. An Azure repos commit fixes Azure Board's bug 742. After the commit reaches the repository's default branch, the bug should transition to its resolved or completed state automatically. Which text should be included in the commit message? The available options are as follows. Option A. Fixes number 742. Option B. Number 742 resolved. Option C. Completed item 742. Option D. Number 742 pending. The correct answer is option A. Fixes number 742. Here's why. The supported resolution keyword and work item reference associate the commit with the Azure Board's item and transition it when the qualifying commit reaches the default branch. Why are the other options not correct? B. A state name after the reference is not the supported resolution syntax. C. The work item identifier is not expressed in the required hashtag ID format. D. Pinning does not resolve the work item. Exam tip. Use supported resolution keywords with hashtag work item ID when a commit should close or resolve an Azure Boards item. Question number 509. Scenario. Azure Boards is connected to a GitHub repository. A pull request must be linked automatically to Azure Boards work item 315 by using AB number 315. In which 2 pull request elements can the reference be included? Select 2. The available options are as follows. Option A. Pull request title. Option B. Repository label. Option C. Pull request description. Option D. Milestone name. Option E. Reviewer assignment. The correct answers are Option A. Pull request title and Option C. Pull request description. Here's why. Azure Boards detects AB hashtag references in GitHub pull request titles and descriptions and creates the corresponding work item link. Why are the other options not correct? B. Repository labels do not provide the AB hashtag linking syntax. D. Milestone names are not parsed for Azure Boards work item references. E. Reviewer assignments identify reviewers rather than linked work items. Exam tip. Use AB hashtag ID in supported GitHub commit, pull request, or issue text to create Azure Boards traceability. Question number 510. Scenario. PowerShell runbooks are stored in an Azure repos Git repository. Every committed change to a designated branch must synchronize automatically to an Azure automation account and publish the updated runbook. Which Azure automation feature should be configured? The available options are as follows. Option A, source control integration with automatic synchronization. Option B, an automation connection asset. Option C, an Azure DevOps service connection with no synchronization workflow. Option D, an Azure Boards service hook. The correct answer is option A, source control integration with automatic synchronization. Here's why. Azure Automation Source Control Integration can connect to an Azure Repos Git branch and automatically synchronize supported runbooks when repository changes are committed. Why are the other options not correct? B. Connection assets store information used by runbooks and do not synchronize source files. C. A service connection alone does not import and publish automation runbooks. D. Azure Boards service hooks operate on work tracking events. Exam tip. Use automation source control integration for supported native runbook synchronization. Use a deployment pipeline when broader runtime support or validation is required. Question number 511. Scenario. A repository uses a custom CodeQL workflow. A pull request from a feature branch reports that no baseline analysis is available. The workflow currently does not analyze the default branch. Which two actions should you perform? Select 2. The available options are as follows. Option A. Add the default branch to the workflow's push trigger and run CodeQL on that branch. Option B. Delete the pull request and create it from the default branch. Option C. Push an update to the pull request branch after the baseline analysis succeeds. Option D. Disable code scanning for the repository. Option E. Create an unrelated second repository. The correct answers are option A. Add the default branch to the workflow's push trigger and run CodeQL on that branch, and option C. Push an update to the pull request branch after the baseline analysis succeeds. Here's why. Code scanning needs a successful default branch analysis to establish the comparison baseline. Updating the pull request branch then triggers a fresh analysis against that baseline. Why are the other options not correct? B. Pull requests normally originate from non-default branches. D. Disabling code scanning removes the required security check. E. A second repository does not correct the missing baseline. Exam tip. Analyze the default branch first, so pull request code scanning has a baseline for comparison. Question number 512. Scenario. A file was deleted and the deletion was committed. Several additional commits have since been added. The file must be restored from the parent of the deletion commit, and the restoration must be committed. Arrange the commands in the correct order. The available items are as follows. Item 1. Git commit. M. Restore deleted configuration file. Item 2. Git restore. Source equals deletion commit, caret, path / to / configuration.file. Item 3. Git log, path / to / configuration.file. The correct sequence is as follows. First, git log, path / to / configuration.file. Second, git restore. Source equals deletion commit, caret, path / to / configuration.file. Third, git commit. M. Restore deleted configuration file. Here's why. The log identifies the relevant commit. The parent of that commit contains the file before deletion, and the final commit records the recovered file in the current branch. Exam tip. To reverse only one deleted file, restore it from a known commit instead of reverting unrelated changes. Question number 513. Scenario. A GitHub repository must be migrated to an empty Azure Repos Git repository. All Git references and history from GitHub must be mirrored, and no unrelated Azure Repos history should remain. Arrange the commands in the correct order. The available items are as follows. Item 1. Git push. Mirror https://dev.azure.com/fabricam/platform/_git/service. Item 2. cd service.git. Item 3. Git clone. Bear https://github.com/fabricam/service.git. The correct sequence is as follows. First, git clone. Bear https://github.com/fabricam/service.git. Second, cd service.git. Third, git push. Mirror https://dev.azure.com/fabricam/platform/_git/service. Here's why. A Bear clone retrieves repository history and references without a working tree. A mirror push replaces the destination references with those from the source. Exam tip. Use a Bear clone and mirror push when all Git references must be migrated to an empty destination repository. Question number 514. Scenario. The Azure Boards app is installed in a Microsoft Teams channel and connected to an Azure DevOps project. Team members must create a new work item directly from Teams. Which command should they use? The available options are as follows. Option A, at Azure Boards Create. Option B, at Azure Boards Subscriptions. Option C, at Azure Boards Sign In. Option D, at Azure Boards Link. The correct answer is option A, at Azure Boards Create. Here's why. The Create command opens the Azure Boards work item creation experience from the connected Microsoft Teams channel. Why are the other options not correct? B. Subscriptions configure event notifications. C. Sign in authenticates the user. D. Link connects the Teams channel to an Azure DevOps project. Exam tip. Link and sign in establish the integration. Create adds a work item. Subscriptions control notifications. Question number 515. Scenario. Engineering leadership wants to measure the percentage of team capacity spent correcting previously completed work, including defects discovered during development and after release. Which KPI should be used? The available options are as follows. Option A, defect escape rate. Option B, deployment frequency. Option C, rework rate. Option D, active bug count. The correct answer is option C, rework rate. Here's why. Rework rate measures the proportion of engineering effort spent correcting or repeating previously completed work. Why are the other options not correct? A. Defect escape rate measures defects that reach later stages or production, not the time spent correcting them. B. Deployment frequency measures release cadence. D. Active bug count measures backlog volume rather than engineering time. Exam tip. Use defect escape rate for escape defects and rework rate for capacity consumed correcting completed work. Question number 516. Scenario. An Azure pipeline uses a container task that requires a service connection to pull an image from a standards-compliant public container registry. Which service connection type should be created? The available options are as follows. Option A, Docker registry. Option B, Docker host. Option C, Azure Kubernetes service. Option D, Azure Service Fabric. The correct answer is option A, Docker registry. Here's why. A Docker registry service connection stores the endpoint and supported credentials used by container tasks to access a standards-compliant registry. Why are the other options not correct? B. A Docker host connection targets a Docker daemon rather than an image registry. C. An AKS connection targets a Kubernetes cluster. D. An Azure Service Fabric connection targets a Service Fabric cluster. Exam tip. Use a registry connection for image pull and push operations and a cluster connection for deployment to an orchestrator. Question number 517. Scenario. A legacy security integration exports Azure and virtual machine event data to storage before a SIEM connector parses and ingests the records. The connector requires a structured, text-based, platform-independent format. Which export format should be used? The available options are as follows. Option A, JSON. Option B, EVTX. Option C, EVT. Option D, proprietary binary. The correct answer is option A, JSON. Here's why. JSON is structured, text-based, and broadly supported by storage-based SIEM ingestion and parsing workflows. Why are the other options not correct? B. EVTX is the binary Windows event log format. C. EVT is the older binary Windows event log format. D. A proprietary binary format is less portable and harder for cross-platform ingestion systems to parse. Exam tip. Use structured text such as JSON when logs must be exchanged between heterogeneous monitoring and SIEM systems. Question number 518. Scenario. A new Azure DevOps project has 3 teams with the following responsibilities. Portfolio coordinators require read-only repository access. Repository leads must create repositories and administer project permissions. Developers must contribute code and create branches and tags. The principle of least privilege must be followed. Match each team to the appropriate built-in Azure DevOps group. The left side items are as follows. Left item 1. Developers portfolio coordinators repository leads. The right side choices are as follows. Right option A, build administrators. Right option B, readers. Right option C, project administrators. Right option D, contributors. The correct matches are as follows. Left item 1. Developers, the correct match is contributors. Left item 2. Portfolio coordinators, the correct match is readers. Left item 3. Repository leads, the correct match is project administrators. Here's why. Readers provide view-only access. Contributors can contribute code and create branches and tags. Project administrators can create repositories and administer project-level permissions and policies. Exam tip. Use project-level groups whenever they satisfy the requirement instead of granting project collection permissions. Question number 519. Scenario. A development team adopts Git flow. The team must identify the long-lived branch that represents production releases and the branch into which completed features are integrated before a release. Select the appropriate Git flow branch for each purpose. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Production-ready code is maintained into the blank branch. The choices for Statement 1 are feature, develop, or main. Statement 2. Integrated pre-production code is maintained into the blank branch. The choices for Statement 2 are main, feature, or develop. For Statement 1, the correct selection is main. Git flow uses main as the production history. For Statement 2, the correct selection is develop. Feature branches normally merge into develop before a release. Exam tip. In Git flow, main represents production and develop represents the next integrated release. Question number 520. Scenario. An Azure Artifacts feed contains NPM packages consumed by several projects. Early adopters must be able to consume pre-release packages, while the default feed endpoint must expose only packages approved for general release. Packages must be promoted after validation rather than republished with different content. Which package management design should be implemented? The available options are as follows. Option A. Use the at pre-release and at release views. Make at release the default view and promote validated packages to at release. Option B. Add a release label to package metadata without using feed views. Option C. Publish approved packages to an upstream public registry. Option D. Store pre-release and release packages as pipeline artifacts. The correct answer is Option A. Use the at pre-release and at release views. Make at release the default view and promote validated packages to at release. Here's why. Feed views expose selected package versions without republishing them. Early adopters can consume at pre-release, while ordinary consumers receive the approved versions exposed through the default at-release view. Why are the other options not correct? B. Package metadata labels do not provide Azure Artifacts view-based promotion and consumer isolation. C. An upstream registry is used to consume external packages, not to promote internally produced packages. D. Pipeline artifacts do not provide package feed versioning and dependency consumption semantics. Exam tip. Publish packages to the feed once and promote immutable versions through views as their quality increases. Question number 521. Scenario. An existing Azure Automation State Configuration deployment sends node status records to the Azure Diagnostics table. A KQL query must return only node-level status records for nodes that are not compliant. Complete the query filters. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Filter category by using the blank. The choices for statement 1 are category equals DSC node status, category equals DSC resource status data, or category equals automation job. Statement 2. Filter operation name by using the blank. The choices for statement 2 are operation name contains DSC node status data, operation name contains DSC resource status data, or operation name contains job streams. Statement 3. Filter result type by using the blank. The choices for statement 3 are result type equals compliant, result type equals compliant, or result type equals started. For statement 1, the correct selection is category equals DSC node status. DSC node and resource status records use this diagnostic category. For statement 2, the correct selection is operation name contains DSC node status data. This operation represents the status of each managed node. For statement 3, the correct selection is result type equals compliant. This excludes nodes already reporting the required state. Exam tip. Distinguish DSC node status data for node compliance from DSC resource status data for individual resource checks. Question number 522. Scenario. A Git repository contains an application that depends on a separately maintained library repository. The library must remain an independent Git repository while appearing as a subdirectory of the application repository. Complete the command git first value, second value, https://github.com/fabricam/shared-library. The available source items are as follows. Source item 1, clone. Source item 2, add. Source item 3, pull. Source item 4, submodule. Source item 5, branch. The destination requirements are as follows. Destination A, first value. Destination B, second value. The first correct mapping is submodule, mapped to first value. The second correct mapping is add, mapped to second value. Here's why. Git submodule add registers the external repository as a submodule and records its URL and path in the parent repository. Exam tip. A Git submodule records a commit reference to another repository while keeping that repository's history independent. Question number 523. Scenario. A team versions a public API according to semantic versioning. Match each API change to the version component that must be increment. The left side items are as follows. Left item 1. Add a backward compatible endpoint. Rename an existing required parameter and break existing clients. Mark an existing operation as deprecated without removing it. The right side choices are as follows. Right option A, patch. Right option B, major. Right option C, minor. The correct matches are as follows. Left item 1. Add a backward compatible endpoint. The correct match is minor. Left item 2. Rename an existing required parameter and break existing clients. The correct match is major. Left item 3. Mark an existing operation as deprecated without removing it. The correct match is minor. Here's why. Semantic versioning reserves major increments for incompatible API changes. Backward compatible functionality additions and deprecations require a minor increment. Exam tip. Use major for breaking changes, minor for backward compatible functionality or deprecation, and patch for backward compatible fixes. Question number 524. Scenario. A configuration file in the main branch must be restored to the version stored 3 commits before the current main tip. The current branch must first be changed to main. Complete the commands. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Run git the blank main. The choices for Statement 1 are reset, checkout, branch, or merge. Statement 2. Run git restore the blank equals main 3, app.config. The choices for Statement 2 are staged, patch, source, or worktree. For Statement 1, the correct selection is checkout. Checkout changes the current branch to main. For Statement 2, the correct selection is source. Source selects the file content from the specified historical commit. Exam tip. Use git restore source to recover selected files without resetting the entire branch. Question number 525. Scenario. The same Azure Pipelines variable is defined at 4 scopes. The effective value must be determined according to Azure Pipelines variable precedence. Arrange the scopes from highest precedence to lowest precedence. The available items are as follows. Item 1. Pipeline Settings User Interface. Item 2. Pipeline Route YAML. Item 3. Job Level YAML. Item 4. Stage Level YAML. The correct sequence is as follows. First, Job Level YAML. Second, Stage Level YAML. Third, Pipeline Route YAML. Fourth, Pipeline Settings User Interface. Here's why. A job level variable overrides a stage variable. A stage variable overrides a pipeline route variable, which overrides a variable defined in the pipeline settings interface. Exam tip. When duplicate variable names exist, the definition closest to the executing job normally wins. Question number 526. Scenario. A platform engineering team must standardize CI/CD processes by providing a centralized GitHub Actions workflow that multiple application teams can invoke from their own repositories. Select and arrange the 3 required actions in the correct order. The available items are as follows. Item 1. Create a YAML workflow file and configure the workflow_call trigger. Item 2. Store the reusable workflow in a centralized, accessible repository. Item 3. Invoke the workflow from a caller repository using the uses keyword. Item 4. Configure the workflow_dispatch trigger on the central workflow. Item 5. Publish the workflow as a GitHub app. The correct sequence is 1. Create a YAML workflow file and configure the workflow_call trigger. 2. Store the reusable workflow in a centralized, accessible repository. 3. Invoke the workflow from a caller repository using the uses keyword. Here's why. To make a GitHub action reusable, it must include the on workflow_call trigger. It must then be placed in a repository where caller workflows have permission to access it. Finally, the caller workflow invokes it using the uses syntax, referencing the file path and repository. Exam tip. Reusable workflows rely on the workflow_call trigger. Composite actions serve a similar reuse purpose but are built differently without workflow triggers. Question number 527. Scenario. 2 independently deployed application environments expose public endpoints. A new version is hosted in the second environment. Initially, only a small percentage of users must reach the new version. The percentage must be increased gradually without replacing either environment. Which Azure service should be configured with weighted routing? The available options are as follows. Option A, Azure Load Balancer. Option B, Azure Traffic Manager. Option C, Virtual IP Address Swapping. Option D, Azure DevOps Agent Pools. The correct answer is Option B, Azure Traffic Manager. Here's why. Traffic Manager weighted routing distributes DNS responses between endpoints according to configured weights, allowing the proportion of users reaching the new environment to increase gradually. Why are the other options not correct? A. Azure Load Balancer distributes network traffic within supported load balancing scopes, but is not the direct DNS-based cross-environment weighted routing solution. C. VIP swapping performs a cutover rather than gradual percentage-based exposure. D. Agent pools provide pipeline execution capacity and do not route application users. Exam tip. Use weighted routing for gradual traffic movement and priority routing for active-passive failover. Question number 528. Scenario. A team uses calendar versioning for build identifiers. A version must include an optional beta suffix that does not change the date-based components. Which calendar component should contain beta? The available options are as follows. Option A, Major Component. Option B, Minor Component. Option C, Modifier. Option D, Micro Component. The correct answer is Option C, Modifier. Here's why. The modifier is the optional textual suffix used for labels such as alpha, beta, preview, or release candidate. Why are the other options not correct? A. Major is a numeric date-oriented version component. B. Minor is another numeric component of the selected Calver scheme. D. Micro is normally the smallest numeric component. Exam tip. Use the Calver modifier for optional pre-release or channel labels. Question number 529. Scenario. Several Azure pipelines consume a YAML template from an external GitHub repository. The pipelines must always use the exact reviewed template content even if branches or tags in the repository are changed later. Which ref should be used for the template repository? The available options are as follows. Option A, a runner label. Option B, a branch name. Option C, a serial number. Option D, a commit SHA. The correct answer is option D, a commit SHA. Here's why. A commit SHA identifies immutable repository content. A branch can move, and a tag can be changed by a repository administrator. Why are the other options not correct? A. Runner labels select execution infrastructure. B. A branch name resolves to whichever commit is currently at the branch tip. C. Repository templates are not versioned through serial numbers. Exam tip. Pin shared pipeline code and third-party actions to immutable commit identifiers when reproducibility is required. Question number 530. Scenario. A developer must clone an Azure Repos Git repository by using SSH authentication. Arrange the required actions in a valid order. 2 items will not be used. The available items are as follows. Item 1. Add the generated private key to the Azure DevOps profile. Item 2. Clone the repository by using its SSH URL. Item 3. Generate an RSA public-private key pair by using SSH keygen. Item 4. Store the private key in the repository root. Item 5. Sign in to Azure DevOps and open the SSH public key settings. Item 6. Add the generated public key to the Azure DevOps profile. The correct sequence is as follows. First, generate an RSA public-private key pair by using SSH keygen. Second, sign in to Azure DevOps and open the SSH public key settings. Third, add the generated public key to the Azure DevOps profile. Fourth, clone the repository by using its SSH URL. Here's why. The key pair must exist before its public key can be registered. Azure DevOps stores only the public key, while the private key remains protected on the client device. Exam tip. Never upload or commit the SSH private key. Register only the public key with Azure DevOps. Question number 531. Scenario. An Azure Artifacts feed receives NPM packages from a build pipeline. Multiple consumer projects must see only package versions that passed all validation tests. The solution must avoid copying packages to another feed. What should the team configure? The available options are as follows. Option A. Make the at-release view the default consumer view and promote successfully tested packages to at-release. Option B. Add the word release to each package description. Option C. Publish tested packages as pipeline artifacts instead of feed packages. Option D. Configure an upstream source to expose every package in @local. The correct answer is option A. Make the at-release view the default consumer view and promote successfully tested packages to at-release. Here's why. Only package versions promoted after successful testing appear in at-release. Making that view the default prevents ordinary consumers from seeing unvalidated versions in @local. Why are the other options not correct? B. A description does not control package visibility. C. Pipeline artifacts are not a substitute for a versioned NPM feed. D. @local contains directly published and saved packages, including unvalidated versions. Exam tip. Use feed views to separate package visibility from package publication. Question number 532. Scenario. An Azure Artifacts feed contains many old NPM package versions that are no longer downloaded. Storage consumption must be reduced automatically while preserving recent and actively used versions. Which settings should be configured? The available options are as follows. Option A. The feed's package retention policy. Option B. The pipeline run retention policy. Option C, the release stage approval policy. Option D, the test result retention policy. The correct answer is option A, the feeds package retention policy. Here's why. Feed retention policies automatically remove older versions after the configured version count and download age conditions are satisfied. Why are the other options not correct? B, pipeline run retention deletes pipeline records and artifacts, not package versions published to an Azure Artifacts feed. C, release approvals do not control package storage. D, test result retention does not delete NPM packages. Exam tip: configure retention on the feed for packages and on the pipeline for run logs and pipeline artifacts. Question number 533. Scenario: a GitHub Actions workflow requires a 256 kilobytes confidential file. GitHub Actions secrets cannot store a value of that size directly. Only workflows in the current repository require the confidential data. Which solution minimizes administrative effort and limits access appropriately? The available options are as follows. Option A, store the unencrypted file as a repository variable. Option B, encrypt the file, commit the encrypted file, and store its decryption passphrase as a repository-level action secret. Option C, store the complete file as an organization-level action secret. Option D, commit the plaintext file and use code owners to restrict it. The correct answer is option B. Encrypt the file, commit the encrypted file, and store its decryption passphrase as a repository-level action secret. Here's why. The encrypted file can exceed the normal action secret size limit. The small decryption passphrase fits in a GitHub secret, and repository scope restricts availability to workflows in the required repository. Why are the other options not correct? A, repository variables are not protected secret storage. C, the full 256 kilobytes value exceeds the supported action secret size. D, code owners controls review requirements, but does not encrypt repository content. Exam tip: for a secret larger than the platform limit, commit only an encrypted file and protect its decryption key as a normal secret. Question number 534. Scenario: an enterprise uses Azure Artifacts. The organization wants to pull open-source dependencies from external registries securely and ensure that internal packages shared with other teams meet quality standards. Complete each statement by selecting the appropriate configuration. Statement 1. To transparently consume and cache packages from an external registry like NuGet.org, configure in the blank. The choices for Statement 1 are upstream source, external service connection, or access policy. Statement 2. To share validated package versions with consuming teams without creating a separate feed, promote the package to the blank. The choices for Statement 2 are feed view, release pipeline, or deployment group. For Statement 1, the correct selection is upstream source. Upstream sources cache external packages locally to protect against public registry outages. For Statement 2, the correct selection is feed view. Feed views control visibility and signal package quality status in a single feed. Exam tip: use feed views, like at pre-release or at release, to promote package maturity safely across different consumer scopes. Question number 535. Scenario: all newly authored YAML pipelines in an Azure DevOps project must reuse the same sequence of 3 build steps. The step sequence must be stored once and referenced by each pipeline. What should the platform team create? The available options are as follows. Option A, a reusable YAML steps template. Option B, a classic task group. Option C, a JSON parameter file. Option D, a standalone PowerShell task. The correct answer is option A, a reusable YAML steps template. Here's why. A steps template defines the shared task sequence once and allows multiple YAML pipelines to include it consistently. Why are the other options not correct? B, task groups are primarily reusable units for classic build and release pipelines. C, a JSON parameter file stores data rather than Azure pipeline steps. D, a single PowerShell task does not define the complete reusable 3-step sequence. Exam tip: Use YAML templates for reusable YAML pipeline structure and task groups for classic pipelines. Question number 536. Scenario. A classic Azure Pipelines release contains two stages. Test deploys an application to a validation web app. Production deploys the approved application to the production web app. After the test deployment, application insights must generate an alert when failed requests exceed the accepted threshold. Production must remain blocked while the alert is active. Select the required configuration for each stage. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. In the test stage, the blank. The choices for Statement 1 are add a task that creates or updates the application insights alert rule, configure a pre-deployment gate, or configure deployment queue settings. Statement 2. In the production stage, the blank. The choices for Statement 2 are configure an Azure Monitor pre-deployment gate, add an automatic redeployment trigger, or configure a post-deployment approval. For Statement 1, the correct selection is add a task that creates or updates the application insights alert rule. The alert must exist and evaluate post-deployment telemetry from the validation environment. For Statement 2, the correct selection is configure an Azure Monitor pre-deployment gate. A pre-deployment gate prevents production from starting while the monitored condition is unhealthy. Exam tip. Configure monitoring in the earlier stage and use its telemetry as a gate before the next environment. Question number 537. Scenario. A CI pipeline validates PowerShell desired state configuration code before infrastructure deployment. The test suite must support both isolated unit tests and integration tests that execute configuration behavior. Which PowerShell testing framework should the pipeline use? The available options are as follows. Option A, PS Script Analyzer. Option B, Test ESC Configuration. Option C, Pester. Option D, PS Code Health. The correct answer is Option C, Pester. Here's why. Pester is the PowerShell testing framework used to write unit, integration, and acceptance style tests for PowerShell and DSC code. Why are the other options not correct? A. PS Script Analyzer performs static rule analysis and style checking. B. Test DSC configuration checks whether a node currently matches a DSC configuration but is not a full unit and integration testing framework. D. PS Code Health reports code quality metrics. Exam tip. Use PS Script Analyzer for static analysis and Pester for executable PowerShell tests. Question number 538. Scenario. A log analytics workspace contains logs with timestamp and request ID columns events. With request ID and continent columns, a query must return log records from the previous 2 days whose related event occurred in Asia. Arrange the KQL statements in the correct order. The available items are as follows. Item 1. On request ID. Item 2. Logs. Item 3. Where continent equals Asia. Item 4. Join. Item 5. Where timestamp ago 2D. Item 6. Events. The correct sequence is as follows. First, logs. Second, where timestamp ago 2D. Third, join. Fourth, events. Fifth, where continent equals Asia. Sixth, on request ID. Here's why. Starting with logs preserves the requested log output. Filtering early reduces the data processed by the join, and the events subquery limits matching records to Asia. Exam tip. Filter each side of a KQL join as early as possible to reduce the volume of data being correlated. Question number 539. Scenario. A repository contains unreachable history referenced only by reflog entries. The entries must expire immediately, and the unreachable objects must then be pruned. Complete the commands. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Run get the blank expire. Expire unreachable equals now, all. The choices for Statement 1 are reset, stash, reflog, or branch. Statement 2. Run get gc, prune equals the blank. The choices for Statement 2 are all, true, now, or reset. For Statement 1, The correct selection is reflog. Reflog expire removes the references that keep unreachable history recoverable. For statement 2, the correct selection is now. Now instructs garbage collection to prune eligible unreachable objects immediately. Exam tip: expire reflog references before pruning objects, and use immediate pruning only when recovery is no longer required. You have completed Part 12 of the AZ-400 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.